Hi, today we're going to look at the triangle sum theorem. If you look here, I have 4 different triangles. I have a right scalene triangle, I have an equilateral equiangular triangle, I have an isosceles obtuse triangle, and I have a scalene acute triangle. So I wanted to try to get a good different mix of triangles where they're all a little bit different, okay? And I've labeled them in the corners, and then I've also traced them so you can see what they look like, because I'm going to do some manipulation with these triangles, because today we're going to look at how the angles go together. And you may remember what the relationship is between the angles from middle school, but I want to do this activity because I think it's a really good visual of that it really is true. So what I'm going to do with each one of my triangles, I'm going to start with this first one with my right scaling triangle, is I am going to tear off the angles. So I'm going to tear off angle A, I'm going to tear off angle B, and I'm going to tear off angle C. Okay, and then I'm just going to set this right back down where it came from. Okay, then I'm going to do the same thing with each one. So I'm just going to tear off my 3 angles from triangle DEF. See if I can get that line back up in there. And then from triangle GHJ. A lot of times when I'm using an H in a triangle, especially on this activity where I'm going to be tearing off the corners, I won't use an H and an I in the same picture, because look what happens when I do a capital I and a capital H in the same picture. My H could look like an H or an I. Okay, and then my last triangle, KLM, I'm going to tear off its corners. Okay, oops, how was this? There we go. All right, so now what I want to do is I want to use angle addition. Remember, our angle addition postulate says if 2 angles are adjacent to each other. So I'm just going to take this angle A, and I'm going to rotate it around, and then I'm going to take angle B, and I'm going to put it adjacent to angle A. And then I'm going to take angle C, and I'm going to put it adjacent to angle B. There we go. All right, I'm going to do the same thing with angle F, angle E. If I can get it to slide over there, I'm going to make them adjacent. And this is kind of why I made sure to tear, so that I could see which ones were still my corners and which ones were not, because if I had just cut them off with scissors, they'd have been nice, clean, neat edges, but it'd have been harder for me to tell which were the vertexes, right? I can tell that the nice, clean point here is my vertex, and then it's a point with a torn edge there, okay? So I'm going to take H, and I'm going to line up G. I can spin this around and try to line it up. Might need 2 fingers. Might have to pick it up. My nails are not participating. Thank you for your patience. Line that up. And then J. That one's sliding better, a little bit. Okay, and my last triangle M, angle L, line up the vertex, make them adjacent, and then angle K, line up the vertex, make them adjacent. All right, so now do we notice anything interesting about these adjacent angles that I've put next to each other? So I've got 3 sets of adjacent angles in each one. Look along the bottom, right? Those line up and make a nice straight line there. Right here, these line up and make a nice straight line. Here, these 3 angles together line up and make a nice line along the bottom. And then these here together make a nice line along the bottom. Okay? So when we've looked at triangles before today, we discussed that they can be classified using their angles and their sides, right? So I've got right and scalene, I've got acute, or I've got equilateral, equiangular, I've got obtuse scalene, or obtuse isosceles, and then this one was scalene acute. But today we're going to look at the angle measures of the triangles, even though I didn't get a protractor and measure these all out, so I don't know the actual measures, except for my right triangle. I know that one is 90. We're going to look and see, what did we notice about these three angles when I put them together? They all had a line underneath them. They're kind of like linear trios, not linear pairs, but like linear trios. And how many degrees are there on one side of a line? There's 180 degrees on one side of a line. So our triangle sum theorem states that the sum of the angles in a triangle is 180 degrees. Okay? So every triangle you'll ever meet in your whole entire life, if you had a protractor and you measured its three angles, it would always add up to 180 degrees. Okay? In the next video, we're going to look at how we can put this into practice.